So today we're in chapter 10 and we're starting to talk about probability. And this particular section, 10.1, is on the fundamental counting principle, and we'll also be doing what's called permutations. So you definitely want to have your notebooks out. There's a lot of definitions in this particular section, and there's a permutation formula that you're going to want, and you're going to want your cheat sheet out so you can add a formula onto your cheat sheet. So first we start off with the fundamental counting principle. What you're going to do here is count every choice for every event. So what does that mean? Well, if you think about a really simple example of going to the cafeteria, you could pick from 3 main dishes, 2 side dishes, and 2 drinks. All of that is going to make up your lunch. So how many lunches can you put together? The fundamental counting principle allows you to try to figure out how many different ways you could put together your main dish, your side dish, and your drinks. So I gave you a sample here. So say for instance for your main dish you've got these 3 things to pick from: sandwiches, burgers, and pizza. Once you decide which one of those you want, then you move to the side dish, and let's say for the side dish you could pick between salad or French fries. If you did that for the burger, you could also pick between salad and French fries. If you chose the pizza, you could also still pick between the salad and the French fries. So once you have the drink or the side dish taken care of, then you go over and do the drink. Once you do the drinks, then you're going to be looking at this next set of arrows. So first you have the sandwich. You choose either the salad or the French fries. Then you could either pick milk. Oh wow, that was weird. Milk or juice. If you went for the French fries, you still could pick between milk or juice. Every single one of these, you could choose between milk or juice. So we have this great big huge tree here. So if I look at this very last column and count up how many total choices I have, that will give me my answer. So I'm looking at all of this last row right here, which is the milk juice row. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 different ways that I could put this meal together. Well, obviously I don't want to have to make one of these great big huge trees, these little choice trees, every time I have something to do, and especially if I had many more choices than just 3 main dishes, 2 sides, and so on. So the fundamental counting principle allows us to count every choice for every event. What we're going to do is divide it up into sections. So how many things are we actually doing? In this case, we've got a main dish, a side dish, and a drink. So it's choice, choice, choice for those 3 categories. Now I have to know how many in each choice. I had 3 main dishes to pick from. I had 2 side dishes to pick from, and I had 2 drinks to pick from. The key here is to multiply these together. So all I'm doing is multiplying 3 times 2 times 2, and that gives me my total of 12 choices. So this is obviously the easy, fast, quick way that you want to do a fundamental counting principle thing. Take choice times choice times choice for each of them, and you should be able to come up with your quick answer. Here I've got a sample of being at a blood drive. So for instance, you hear about S-Cube doing their blood drive here at school. Blood drive for blood, it is labeled 4 possibilities: A, B, AB, and O. There are 2 RH factors. It's either positive or negative. For instance, my blood happens to be A positive. And then we're going to go with 2 genders, male and female. How many different ways can the blood be labeled? Well, in this particular situation, we've got 3 things that we're talking about. We've got the blood itself, how it's labeled, so that's my first choice. I've got the RH factor, that's my second choice, or my second category, and then I've got the male or female piece, and that will be my third category. So how many different ways can we label the blood? Well, our blood is labeled AB, AB, and O, that's 4. 2 RH factors, and 2 sexes, male and female. So my total, 4 times 2 times 2, 8 times 2, I've got 16 different ways then we could label our blood. Now we're looking at something called the fundamental counting principle with repetition versus without repetition. One of the very common examples that they have for something like this is try to figure out how many ways you could put together your license plate. Have you ever thought about that when you just look at your Minnesota plates, how many different ways that they could put those together? Well, it depends on if you're going to repeat letters, repeat numbers, or not repeat them. In Minnesota, you can repeat them if you want. So we could figure out how many different ways we could make up a license plate. Well, we're going to do an example first where we're going to talk about 3 letters, and that will be followed by 3 numbers. The numbers are digits. Now you have to keep in mind here that digits are the numbers from 0 up through 9, and we do have 10 of those. So counting 0, you've got 10 digits to pick from. Letters in your alphabet, you've got 26 letters in your alphabet. All right, so if we want to try to figure out a license plate question, how many different ways could I make that with repetition? That means I could repeat the letter if I want. So your letters, I've got 26 letters to pick from. My second choice, I still have 26 letters to pick from since I am allowed to repeat them. And my third choice, I still have 26 letters to pick from. My digits from 0 to 9, I have 10 choices. So I have 10 choices for the first digit. I'm allowed to repeat, 10 choices for the next, and 10 choices for the next. Now these again are all multiply. So you need your calculator, you're going to plug that in, and you will notice that this is huge answers when you're doing these. 26 times 26 times 26 times 10 times 10 times 10. Hopefully you come up with that on your calculator. Now if you do this exact same question without repeating, that just means that once you have your first digit or your first letter chosen, either one, you can't repeat that. So I have 26 choices for my first position. Once I use that letter, I can't repeat. I'm down to 25 choices, and my next letter, I'm down to 24 choices. Moving to the digits, I have 10 to pick from. Once I've used that, 9, and then once I've used that one, 8. Punch that into your calculator, and remember this is all multiplying again. Again, you'll have a huge answer. And hopefully you're at 11,232,000 choices, different license plates that you could make. Next example is one with the garage door code. Most everybody who has an electric garage door opener, you've got a code box on the outside, and you can figure out how many different ways you can put in your code. All right, so we're going to do this one where we only have the numbers 0, 1, 2, 3, and 4 that are used on our garage door code. How many codes are there if digits cannot be repeated? Well, if I'm going to use, let's see, 5 spots. So we've got 1, 2, 3, 4, 5 digits. We've got 5 spots to fill. I can repeat them. I have 5 choices for the first one. I have 5 choices for the next, and so on down the line. So we're going to just multiply those together. If you can remember your flashcards, 5 to the 5th. And then how many different codes are there if we cannot repeat? 5 choices for my first digit. I've used that digit. I can't use it again. So it's 1 less, and so on down the line. 5, 4, 3, 2, 1. 120 different codes that we could put together if we do not repeat the digits. Next thing we're talking about is something called a permutation. So this is your first definition you need to write in your notebooks for sure. Permutation is an ordering of objects where the placement matters. Permutation is an ordering, so the placement matters, order matters. Anything that talks about a competition, first, second, or third place, elections, you're going to vote for a president and then a vice president and then a secretary. You can't be both the president and the vice president at the same time. Picture lineups, you're going to take a photo, a family photo, and you're going to line everybody up. You obviously can't have Grandpa Joe sitting at the front, and he can't be sitting in the back chair as well. So anything where an object can only be placed in one spot, that would be considered an ordering, in which case it is a permutation. In this particular sample, if I have the letters A, B, and C, how many ways can they be permuted? How many ways can they be ordered? Well, I know I've got 3 letters to pick from, so I have 3 choices in the first position. But once I use that first letter, I can't use that letter any longer, which means I now only have 2 choices after that. And once I use that choice, then I only have 1 choice after that. So do you see, it's the exact same way as we did the repetition with the license plate or the garage door code, where once we use the letter, we can't use it again, and then we have 1 less. That's exactly what we're doing here. So we've got 6 different ways that we can put these letters together. When you have something like this, where it's just 1 digit and then 1 less and 1 less and so on, that is called a factorial. So there's another term you'll probably want to write down. It's called a factorial, and the mathematical symbol for a factorial is the exclamation point. So the factorial symbol in math is this thing called an exclamation point. But please don't say exclamation point when you're talking about it. You say the word factorial. So this, what I circled right here, would be written as, or it would be said as 3 factorial. We can find the factorial button on our calculator. The first thing you type in is whatever number you're looking for. So for instance, if I wanted to calculate 3 factorial, I would type in the 3 button first. Then you're going to go to your math button. And I'm going to bring up my calculator in a second to show you if you can't remember. So go to your math button. You're going to arrow over 3 times, and you're going to have all the different choices for probability that we'll be doing this chapter. You'll arrow over 3 times, and the factorial button is choice number 4. All right, so let's bring up my calculator. All right, so we're going to type in the 3, and my math button way over here on the left-hand side. Then we have to arrow over 3 times to where it's going to have a black box around the word PROB. That stands for probability. And then choice number 4 is your factorial button. So I'm going to calculate 3 factorial, hit your enter button, and we get 6, which is what we saw when we were doing our last example, 3 factorial at 6. All right, so try practicing with your calculator. Punch in 9 factorial. 9 factorial, 9, 8, 7, 6, 5, 4, 3, 2, 1. Hopefully you all got 362,880 as your factorial answer. Okay. Let's try this example with our factorials. TV has 8 news stories, so your nightly news has 8 news stories that they're going to be talking about. How many different ways can they be presented? Well, if you think about that for a second, you've got 8 stories, 1, 2, 3, 4, 5, 6, 7, 8. They're going to have 8 choices for the story that they could talk about first. Well, once they talk about that particular story, they're not going to say the same story again in that nightly news, which means they're only down to 7 stories left to talk about. Once they do that 7th or that next story, then they're down to 6, and so on. So this, when you are ordering the stories that you're going to talk about on the news, this is a factorial, which would then just be written as 8 factorial, which you can then punch in your calculator and find out what your answer will be. So try that real quick. 8 factorial. And hopefully you get 40,320. Part B, what if only 3 stories air before the first commercial? Well, I'm only going to air 3 stories. So I'm just going to, for helping you, I'm just going to talk about 3 blanks to represent those 3 stories. Well, remember, I still have 8 stories total. So I have 8 that I could pick from. I do the first story. I now have 7 stories to pick from. And then I only have 6 left over to pick from. So to do 3 stories before the first commercial would be 8 times 7 times 6. 336 ways that I could put those 3 stories together. This specific amount that I'm doing, the number of permutations of n objects taken r at a time, This is a specific formula in mathematics called the permutation formula, and it only talks about if I'm doing a certain amount of objects out of a grand total. So in this particular case, I had 8 objects, but I was only going to do 3 of them at a time. So it's a few of the particular total that you want to talk about at a time. That notation is right here, and you're going to have 2 different subscripts. So it's NPR, N refers to your total, so I have 8 total things, and I'm going to permute them, I'm going to order them 3 at a time, 8P3. Now this can also be done on our calculators. Before we get to the calculator, I'm going to show you the actual formula for this. So the formula for NPR, the formula for ordering a few objects out of a total, is this formula. You need to write this in your notebook for sure, and this needs to go in your cheat sheet for your final. N factorial over N minus R factorial. Your total over total minus how many you're going to do, in parentheses, and then factorial. So if I wanted to write 5p3 in the formula, it would be 5 factorial over 5 minus 3 factorial. And to see what that looks like written out, 5, 4, 3, 2, 1 over 5 minus 3 is 2 factorial. 2 factorial is 2 times 1. Now, what am I looking at? Well, I could cancel, and I'm just multiplying 5 times 4 times 3. 20 times 3. The answer to this should be 60. You should be able to use this formula by yourself without a calculator for smaller numbers. So please practice that a couple times. You will have to do a couple of these with the formula without your calculator. All right, now we're going to try this on the calculator. We're doing this exact same example, 5p3. When you do this, again, you need to type in the first n value first on your calculator. So how many total objects would be 5? Then you're going to your math button again, arrow over 3 times. You're going to take choice number 2. Choice number 2 will specifically say NPR. That's what choice number 2 will say. And then you type the last digit, which is how many we're going to be ordering at a time. So in this case, we're going to order 3 at a time. Okay, so let me pull up our calculator again, and we're doing 5p3. All right, so we type the 5, then we go to our math button, arrow over 3 times to probability. There's choice number 2, NPR, so take choice number 2. Now do you see how it shows up already as 5p? Then you can type your 3, and then you can hit your enter button. And we come up with 60, which is what we got when we did it by hand. Now I want you to try your own. Try 8p5. Try 8p5 and see if you can come up with the solution for that. Hopefully you came up with 6,720. Next example. How many different ways can 4 raffle tickets be selected from 50 if each ticket wins a different prize? We have a total of 50 objects, and we are only going to be choosing 4 of them at a time. 50p4. 50 objects ordered 4 at a time, chosen 4 at a time. You could plug that in your calculator. Be careful, it's going to be huge. Hopefully you match this, 5,527,200. Next type of example is called distinguishable permutations with repetition. And the examples that they give in the book are always words. They want to know how many different ways you can rearrange the letters in a word to come up with something else. And it doesn't have to be a word that makes sense. These permutations are called distinguishable. Distinguishable also means distinct or different. And repetition means that you've just got things that repeat over and over again. So, formula for this one. Write this one in your notebook as well. Put this one on your cheat sheet. N factorial divided by S factorial, dot, dot, dot. The S stands for any letter that happens to repeat in the word that you're looking at. and you're going to keep multiplying by as many letters as you've got that actually repeat. All right, so that's kind of confusing. Let's practice with the word Miami. First of all, I need to know what's my total. How many total letters do I have in the word Miami? 1, 2, 3, 4, 5. So it's 5 factorial. Over. Do I have any letters that repeat? Yes, the M repeats, and there are 2 M's, so I do 2 factorial. Do I have any other letters that repeat? Yes, I have an I that shows up twice, so I bring in another 2 factorial. Do I have any other letters that repeat? No, I do not. So this one is then ready to be calculated. I'm just going to show you by hand how this one will work out. 5, 4, 3, 2, 1. 2 factorial is 2 times 1. Another 2 factorial is 2 times 1. The first set of 2 1s can cancel. I've got 5 times 4, which is 20, times 3 is 60, and 60 over 2 would be 30. So there are 30 different ways that I could rearrange the letters of the word Miami into something distinct or distinguishable. All right, let's try it with the word swimming. 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. Do I have anything that repeats? S, no. W, no. I have 2 I's. I have 2 M's. The N and the G also don't show up repeated. So when I do this one, and you can use your calculator if you want to, you have to be really careful here. So I'll bring up my calculator again. We've got 8, math, arrow over to probability, take choice number 4. 8 factorial divided by, now remember there were 2 things on the bottom. 2 factorial, 2 factorial. So I'm dividing by a quantity of 2 factorial, 2 factorial, okay? So there's 2 ways you could do this, and I'm going to opt for the quicker way. 2 factorial, you'll have to type your 2 button, go to the math button, arrow over to probability, and so on. But 2 factorial is so small you should be able to remember this one in your head. 2 factorial is 2 times 1, that's 2. Another 2 factorial is 2 times 1, which is 2. What's 2 times 2? 4. So I could just put it in as divided by 4 and come up with my answer. If you're going to do it the long way, if you have a letter that repeats multiple times, be careful, you have to put this in parentheses. 8, math, probability, factorial, divided by 2, math, probability, factorial, times 2, math, probability, factorial, close the parenthesis, equals 161280. Oh, and I forgot to hit the divide sign. See how you mess up sometimes? All right, so let's see if I can bring that back. Second entry, and I'm going to back up. Right there, and I'm going to insert my divide sign, and then I'm going to hit enter. There's my answer, 1080. Same thing as I got if I did 8 factorial divided by 4. So you can do it this way with the divide by parenthesis, 2 factorial, but it's a lot more work, a lot more punch in your calculator than just knowing that 2 factorial times 2 factorial is 2 times 2, which is 4. So I would opt for this way, a little quicker. All right, I think I have one more sample for you. I want you to try to find how many distinguishable ways you could put together the words, the letters of the word Mississippi. And this one we're going to be checking tomorrow. Okay, so we're going to check everybody's notebook. You better have an answer for me. How many distinguishable ways do you have to put together the letters of the word Mississippi? Okay, good luck.